Hello everyone, welcome to my channel. So today we are going to do Leetcode bi-weekly question. So here's the third question of bi-weekly challenge. So let us first read this question, then about the constraint, then finally the coding part for the same. So here, visit array position to maximize the score. So here we are given zero index integer array nums and a positive integer x. You are initially at position 0 in the array and you can visit other positions according to following rules. If you are currently at position I, then you can move to any position j such that I is less than j. Basically, you can move towards the right side of the array, not towards the left side. And then for each position I that you visit, you get a score of nums of I. If we move from a position I to a position j and the parities of nums of I and nums of j differ, then you lose a score of x and we are required to return maximum total score you can get. Initially, we have nums of 0 points. So now here the thing is that we are required to choose our numbers in such a manner that it should be towards the right hand side of our present element which we have selected, and we are at the end required to return the maximum total score which we can get. Now the thing would be that if we want to have the maximum total score, so as per here some constraints are given that we are required to decrease the score by x if the parity changes. So in that context, surely that will affect the choosing of the element, right? So because of that only, we are required to check that can we take this element or we can't take this element. So in that context, it becomes a question of recursion. And now comes the part that would recursion really work here? So for that context, we are required to check the constraint. So as per the constraint, here as constraints are up to 10 raised to power 5, means length of the nums is 10 raised to power 5 and a element can go up to 10 raised to power 6. So in all this context, we can't just use recursion. We would be required to memorize as recursion so that as per the given constraint, we can easily get our answer. So basically now this question becomes the question of DP. So let us go ahead that how we are exactly required to do this question. So first is this first example which is there. So from this examples, I'll let you know that how we are required to code this question. So now the thing is that as per this first example, so first they have given that initially we have nums of 0 points, right? So we would be having this number of points already with us. But the thing is that we need to check that can we choose this three or we should discard this tree and choose some other number. Basically, the recursion tree which we make, right? So according to that, we can check that at this means we have two options that either we can take this tree or we cannot take this tree. Then comes the part that either we can choose the six or cannot choose the six. So in that context only, since this is a take and this is the not take. In that context only, we will be going ahead that can we choose it or cannot or can't we choose it. So that's the thing which we are required to code. Now, the other part of this question is that we are required to check for the parities as well. That as per the parities, if we choose a particular, right, then in that context, if the parities are different, then we are also required to subtract this 5. So that would be the thing here. And now, as per this thing only, we are having two variable parts. One variable part is the index of this particular array, which is basically changing as per selection of what could be the maximum possible score till now, and the and not only the till now, but we are required to check that yeah, out of these, what could be the maximum one. And then the second variable part is this x which is there, not this x, basically the parity which would be there as per this particular question. it is given that parities would be changing, right? So when parity would be changed, then we would be required to subtract that loss, right? So that's why these are the two variable parts, means the index and the parity. So as per this thing only, the state of the DP would be on this basis, and the transition would be on the basis of that at a particular point we are required to check that if we take that particular, then how it would be, and if we don't take that particular element, then how the things would be. So this is how the transition of this would take place. Now, because the parity is also playing a great role in this, because parity is also playing the role in this particular question. So that's why first we will check that what exactly is the parity of the first element which is there, and then that only we will be uh, uh, basically we will take that parity, and then that would be as the input to our recursive function. And going ahead, we will be changing that parity on the basis of that what is parity of our present element, and that is how we will be proceeding. So let us go ahead with the coding part for this particular question, and after that we will be discussing about time complexity and the space complexity for this question. So here the first thing is that this is the function which we are going ahead. So here the first thing is that we are here first checking the parity of the first element which is there. So here, if this is the state, that simply means that now the parity is 1. So that's why we will be passing here 1, else we will be passing the 0. This 1 basically indicates the index. This is this vector which is being given to us. And here we are including that thumbs of 0. Why? Because in the question only it is mentioned that initially we have thumbs of 0 points. So that is the thing. And whatever would be returned from this particular, that would be added up to this, and that would be returned. Means either from this or from this. So this is the thing. So now comes the part that how we are making this function. So basically, at the first point, I already told that it is a recursive question in which we are memorizing the same. So that is the only thing which we are doing. So as part of the recursive uh, function, so see, the recursive function always have a base case, and then it will be having a recursive function, recursive function which would be basically recurrence relation would be there, and then finally the return part for the same. So here, because we are required to return this long n, right? So whatever we will be adding up to the same. So here this recursive function should also return the long n part. So that's why here the return type is long. And in that particular manner only, we will be having our recursive function functioning in that manner. So now first is the base case that if our index reaches the nums dot size, basically the ending, then we are required to return 0 at that point. If our DP of index parity not equals to -1, because here at this point we are basically filling our DP with -1 with this, and that's why here if it is not equals to -1, that simply means that it is having some value, so we will be returning that. Now comes the main part. First we are at every point we are making our sum equals to 0 at the starting, and then here we are not taking anything. We are just calling the functions again and again, but when this particular means when it will be at its last function, and then when it is required to backtrack, then at that point we are keeping in mind what all the take conditions would be there, because the main calculation will start at that point for the take part. So here, if our parity is different in this manner, or if our parity is different in this manner, basically the parity which we got from the function at recursive function at that point is 0, and the index and the parity with the index means element at that particular index is 1 at this particular point. then here we can clearly see that it having a different parity. And same goes with this point. Now, if either of these condition is true, then the thing would be because the parity is different, right? So because of that thing only, here as was mentioned that if parities are different, then we are required to lose our score by X. So that's why here we will be checking that at this point sum would be equals to maximum of whatever sum was there till now, and at that point we will be calling our function. Then basically we will be choosing our this path of our internal recursive tree and adding the nums of index at that point and subtracting the loss from the same because the parity is different. But one more thing is there. So here we have included this, right? So for the next, we will be going ahead with would be the next index after that. And here we will be changing the parity because here the parities were different. So whatever parity was earlier, now it would be changed at this point because the present element which is there, it is having a different parity. That is the reason. And passing that same and the loss, that is already same because these are already the input variables for this particular function. Else, if the parity is same, so in that context, we are just checking that what is the maximum either sum, or if we choose this path, then in that context, are we getting the maximum or not at that particular point? And then just simply adding the nums of index is the present element which is there. So after checking both of these, here also again it will be calling the recursive functions for checking that particular path. And after these if else condition, then at that point we will be having the at that particular index with that parity, whatever some value would be there, we will assigning the same, and this would be directly returned to its parent caller function. So this is how at every point we are calculating the sum, and then that would be returned, and that is how our answer would be. Now comes the part that would be the time complexity and space complexity for this particular question. So time complexity here would be as per the states of our DP. So here we can clearly see that this is the n and this is the 2. So that's why the time complexity would be n into 2, and even the space complexity as well would be n into 2 in terms of this DP as well, in terms of our internal recursive tree which would be there. So this was all for this particular question. If you have any doubt, you could comment it down. So yeah, thank you.